So in this lesson, we're going to take a look at inverse trig functions. And the graph that's on the screen is the y equals sine of x from negative 2 pi to 2 pi. Then hopefully one of the concerns that you see initially is that this graph is not actually invertible. For something to be invertible, it must be 1-to-1. In other words, it must pass the vertical and horizontal line test, which clearly this doesn't. So what we do is we understand that the graph of sine goes on forever and ever in both directions. So knowing that it's just a repeated succession of oscillations, we go ahead and we take out a piece of it, and the piece that has been agreed upon is between negative pi over 2 and pi over 2. So if I take that piece and I understand the rest of the graph is going to do the same thing, so let's just focus on that one part, it's going to allow us to construct the inverse function graph that we're trying to study. So if you remember back from algebra, to find an inverse, all we have to do is simply interchange coordinates. So on my graph, currently, I have the point negative pi over 2, negative 1. I have 0, 0, and I have pi over 2, 1. So for the inverse function, I'll go ahead and I will flip the coordinates. So 1, pi over 2, 0, 0 stays the same, and negative 1, negative pi over 2. So these are the 3 points now that I'm going to use to construct the graph of y equals the inverse sine of x. So I'll put those points on the graph. Here's going to be 1, here's pi over 2, 0, 0, and negative 1, negative pi over 2. So connecting those dots, this gives us the graph of the inverse sine function. Now, a couple things that we have to remember. We started off with something that was not a one-to-one function. We picked a part of it that enabled us to create this inverse function. Now, when we look at just the inverse function, it's important to understand that the range of the inverse function you can see is negative pi over 2 to pi over 2. Now, when talking about x's and y's, the range and the y coordinate go hand in hand. So essentially what this is saying is that all y values are bounded between negative pi over 2 and pi over 2. So now if I come up here and I make a simple substitution noting that y equals the sine of x, I've just now determined or concluded that the inverse sine of x has to always be a number between negative pi over 2 and pi over 2, which is really important because if you think backwards, the graph of the inverse trig function would not have existed without the graph of sine of x. The graph of sine of x would not have existed without the unit circle. So everything always goes back to that unit circle. So on the unit circle, and this is big, on the unit circle, inverse sine can only exist between pi over 2 and negative pi over 2. So that direction and that direction, which means that on the unit circle, inverse sine can only exist in quadrant 1 and quadrant 4. So quadrant 1 and quadrant 4, those are the only places that when we draw our triangles that we're going to ever be able to get an answer for inverse sine of x. All right, so the next graph that we'll take a look at will be cosine of x. I also have it graphed on the screen from negative 2 pi to 2 pi, similar to sine. We can have a similar conversation about how it's not one-to-one. So then what we'll need to do is we'll need to pick out a part of it that is one-to-one and then extrapolate the results. So what we decide is to take out the part here between 0 and pi. And on the graph, you can see that we have points 0, 1, pi over 2, 0, and pi, negative 1. For the inverse function, inverse cosine of x, once again, we'll interchange those coordinates. So what was originally 0, 1 is now 1, 0. We have a 0 pi over 2, and we have a negative 1 pi. So over here, here's 1, 0. 0 pi over 2, if we call that pi over 2. And then the final point would be a negative 1 and a pi. So up here, connecting those dots, there sits the graph of the inverse cosine. All right, and so again, a similar conversation would be that the y's, the range, if you will, here are going to be bounded between 0 and pi. With a nice substitution, the fact that inverse cosine equals y, you can see that the inverse cosine is bounded between 0 and pi. So on the unit circle, here's 0 over here and here's pi over here, you can see from 0 to pi, the only place that the inverse cosine function can exist when we draw our triangles will be in quadrant 1 or quadrant 2. So for inverse cosine, we're looking for angles in quadrant 1 or quadrant 2 that satisfy the given conditions. All right, and finally we'll take a look at the graph of tangent of x. Now the graph on your paper has a little bit more to it than I have on the screen, but even if you can visualize it out a little further, the graph will continuously keep doing this, and you can see therefore not one-to-one. The part that I have on my paper is the fundamental cycle, which that's the part that we're going to take now, and we're going to interchange coordinates, and that way we can then graph the inverse tangent function. Originally our points here are at pi over 4, 1, 0, 0, and negative pi over 4, negative 1. We'll flip those around to 1, pi over 4, 0, 0, and negative 1, negative pi over 4. So the graph of the inverse tangent, we've got, let's see, 1 pi over 4. We'll have the point 0, 0, and we'll have the point negative 1, negative pi over 4. You can also see that the vertical asymptotes in the graph of tangent were x equals negative pi over 2 and positive pi over 2. So now we're going to have horizontal asymptotes at y equals pi over 2 and negative pi over 2. So that way when I connect the dots here, you can see as x goes to positive or negative infinity, we're going to be bounded inside those asymptotes that we just drew in there. And so just as before, we can make some observations that between negative pi over 2 and pi over 2, not including because we have asymptotes, would be where the y's are allowed to be. By a substitution, negative pi over 2 is less than inverse tan is less than pi over 2. So on the unit circle, similar to how sine was, if this is pi over 2 and this is negative pi over 2, from there to there, you can see that inverse tan will only ever exist in quadrant 1 and 4. So again, all of that information will be incredibly important when we start working these problems. It seems a bit trivial now, but it'll be very, very important. So I'm going to go ahead next and I'll clear the screen, and then we'll go ahead and summarize what it is we found. Similar discussions can be had for the other 3 inverse trig function graphs. We won't talk about them here. You can certainly come up with them on your own, but let me go ahead and clear the screen, and then we'll summarize what we found. Okay, so in summary, you can kind of see I've got these grouped a little bit on the screen. We did inverse sine, and inverse cosecant is going to be the same way. So these 2 graphs will allow us to come up with answers then only in quadrants 1 and 4. Similar for inverse cosine. We did that one. We found out that it was only allowed in quadrants 1 or 2 on the unit circle. Inverse secant is the same way. Tangent, the inverse tangent we found was quadrant 1 and 4. And then inverse cotangent's actually quadrant 1 and 2. It's like that because of how the fundamental cycles for the originals are different. And those are the two that were a little bit strange compared to the other ones.